Within the Maths A level, there are two types of sequence you may wish to be familiar with, one of which is the geometric sequence. This will be a row of numbers with a common relationship between them, in this case defined by where the nth term within that sequence is the first term a times by a common ratio to the power of n minus 1, where n is the number of terms in the sequence. Now, by common ratio, I mean that we're timesing by a fixed common value to get from one term to the next. So, for instance, a geometric sequence would be 2, 6, 18, and 54, because each time we are timesing by 3. So in this case, A would be 2, R would be 3, and if we wanted like the 54, that would be the fourth term. So that's to get an individual term. The other formulas you may want are for sums. So if we want the sum of the first n terms and the sum of these first 4 terms, we'll have now a times 1 minus r to the power of n, close bracket, and then underneath all of that, 1 minus r. Then we also, for the geometric, have a possibility to work out the sum to infinity. Now, we can't do this with the other type of sequence that we talked about, which was arithmetic, because in arithmetic, you're just adding terms continually onwards. You're always going to get a bigger and bigger term. Technically here, we are also always getting bigger and bigger, but in the event of a converging series, a converging sequence, that is to say that your common ratio is a value, that means each subsequent number is getting smaller, then as you add on each subsequent term, you aren't adding anything notable. So you get to a point where just every new term is negligible, you've tended towards a fixed value. So this will just be a over 1 minus r. And the reason for this is, if r, for this to happen, has to be some value between probably 0 and 1. So as n gets bigger, this decimal value is going to get a lot smaller and smaller. And so we have basically 1 minus nothing really, just negligible, and a times 1 will just be a. For the proof of why that's the sum, though, because you could be asked, as well as just a general question involving a scenario and you have to pick out your a, r, and n, you may be asked to prove why this is the sum of the first n terms. Well, if you ask that, you can give the following. If you were to give just a general sum of these terms, rather than a single formula, but actually add them up, you would have, so a is your first term, add ar as your second, add ar squared, and so forth, until you get to ar n minus 1. If then you were to times this sum by that same value of r, so you get rsn, a would now be ar will be ar squared, and that's plus ar cubed, all the way up to ar to the power of n. It's up to you how many terms you choose to show, so long as you get some indication of an initial ascending power of r, starting from having no r, going up until your final term here. Acknowledge that that's the endpoint. Now, if we were to then subtract these equations from each other, you have Sn minus Rsn is the same as, so we'll start with A, but then AR is going to minus with AR to disappear. AR squared is going to minus with AR squared to disappear, and so forth with your AR cubed, and so forth with your AR to the n minus 1, leaving you with the only other term that doesn't cancel with something being this AR to the power of n. So that should be a minus. So Sn minus Rsn equals A minus AR to the power of n. Factorize both sides of this to take the Sn as a common factor out here. That leaves you with the other factor of 1 minus r. And here, take out the a, you have 1 minus r to the power of n. Finally, if you just divide through here, you get the sum of n is the same as A times in brackets 1 minus r to the power of n divided by 1 minus r. And there's your proof. Now that we have that, let's just turn our attentions to an example of a more regular question. So the cost of insurance for the first year is £200, and every following year the cost increases by 12%. So we're increasing not by a fixed value, but by a 12% of the current year to get the next year. It's a different actual monetary value each year. Find the cost of the fifth year and the total cost of 15 years. Well, let's start off just by identifying our A, our R, and our N. A, we can say is going to be 200. For our R, it's not 12. If you think about what you may do with compound interest, if you remember that, because we wanted to increase our money, you want to times by 1 to keep everything you currently have. And then you have decimal point, and then this percentage here as a decimal. So the common ratio is 1.12. Times by 1 to keep what you have, then times also by 0.12 to increase it by 12%. And lastly, our N here, in the first example, that's going to be 5. So because we're in the first part of the answer, specifically just looking at the fifth year, the fifth term, we'll do 200 times 1.12 to the power of 5 minus 1, because it's n minus 1. Plug that in your calculator, and rounding to 2 decimal places, because it's money, you'll get a value of £314.70. As for the second part of the answer, because we're now looking at the total cost, that's going to be the sum over the course of 15 years. So the sum of 15 years is going to be 200, and then that's times 1 minus the 1.12 to the power of 15 over 1 minus 1.12. Once again, you just plug that in your calculator, and that will get you a sum value of £7,456 if we were just to round to the nearest pound. If you were to do it to any decimal places, you would do it to 2 decimal places because it's money. Now, if we're okay with this, let's have a go at just a question of your own. What if we were to say that the first term of a geometric sequence is 20, and that the common ratio is 7/8. What's the smallest value of n for which the sum of to infinity minus the sum of those n terms is less than 0.5? Consider what information you have and what formulas you may need. Pause the video, have a go for yourself, and then press play again when you're ready to compare. So, first of all, we can work out just what the sum to infinity is. We might as well, it's a fixed value. So we'll say the sum to infinity is going to be 20 over 1 minus 7/8. And if you put that in the calculator, you get a value of 160. Therefore, when we have the sum of infinity minus the sum of the first n terms, we'll have 160 minus. Now it's going to be 20, and 1 minus 7/8 to the power of whatever this n is, over 1 minus 7/8, and this being less than 0.5. Now we know that 20 over 1 minus 7/8, we just said, was 160. So it's strictly speaking 160 minus 160 times this bracket, so minus 160, minus minus becomes a plus, so 160 lots of 7/8 to the power of n, less than 0.5. 160 minus 160 cancels, so you just have 160 of 7/8n less than 0.5. What we can do though is now just divide this 160 over. So 0.5 divided by 160. And then what you can do is you can take logarithms. If you haven't come across logarithms yet, do be sure to check out that video. But with the whole point of logarithms is on your calculator, where you have that button which says log, and you've got a small square and then a big square. In this small square, you're going to put this fraction here, so do log, and down here, 7/8. And then in the big bracket here, we're going to do the 0.5/160. That would give you a value of 43.19 if it's 2 decimal places. Now obviously this is an equal sign, not an inequality. We're looking for an entire n value where n has to be an integer, because you can't have like a 1.5th place in a sequence. So we're either going to have 43 or 44. What you can do on the one hand, maybe if you just want to use 43 and 44 and see which one works. Or if we just want to think about it this way, because we want this to be a smaller thing, if you do a fraction to a bigger power, the bigger power makes it the smaller value. So in this case, 43 would make this bigger than if it was 44. We want it to be small though, so we'll say that n has to be 44 for the smallest value for which this works. If we're good with that, let's just finish off by looking at an actual exam question. So, the first three terms of a geometric sequence are 4p, 3p plus 15, and 5p plus 20, respectively, where p is a positive constant. First of all, show that 11p squared minus 10p minus 225 equals 0. So, whenever you have a show that question that is in showing a quadratic, we're going to have to look at the details that the question has given us, somehow find an equals in there, so something equals something, and then rearrange things around that equal sign and simplify until you just have 0 on one side and everything else on the left. All we have here, though, are the expressions in terms of p for these first three terms. So we know that the first term, which would be just a, is going to be 4p. The second term, which would be ar, is 3p plus 15. And the third term, which would be ar squared, is 5p plus 20. Now what we can say from here is that actually, if we were to divide a term by the previous one, that should leave us with r in any case. So ar squared divided by ar is going to leave, well, a's will cancel, and r squared divided by r leaves you with a singular r. And ar divided by a will again just leave us with r, because the a's will cancel. Therefore, if we would say that 5p plus 20 over 3p plus 15, that will give us the same value as 3p plus 15 over 4p, because they both will equal this value of r. If you now have fractions that are equal to each other, what we'll do is we'll cross multiply, so bring the 4p up here, so it'll be 4p times the 5p plus 20, and on the right we're going to have 3p plus 15, and times 3p plus 15 again. Expanding these brackets on the left, 4p times 5p is 20p squared, and 4p times 20 is 80p. And this will equal 3p times 3p is going to be 9p squared, 3p times 15 is going to be 45p, 15 times 3p is 45p, and then 15 times 15 is going to give you 225. Just bringing then everything onto the left-hand side, so all of these are positive, so they're going to become negative on the left-hand side, so you have 20p squared minus 9p squared leaves you with 11p squared, 80p minus, well, 45 minus 45, that's like 80 minus 90, so it's just going to give us minus 10p, and then this 225 just becomes a minus over here, because there's no other whole number to compare with. And once you've moved all these away, that leaves you with 0, This is a quadratic we had to show. Next, therefore, we need to show that p will therefore equal 5. For this, we can either use the quadratic formula or try to break this down into two brackets. Because we have both a coefficient in front of the p squared and there's going to be a number of factors 225, I'm purposely just going to think it's quicker if we do the quadratic formula. It's up to you, whatever works. Your calculator may in turn actually have a setting that solves this for itself. However we do this, say here, so our a is going to be 11, b is going to be minus 10, and c is going to be minus 225. So putting that in the quadratic formula, minus b, so minus minus 10 is just 10, and then plus or minus square root minus 10 squared, making sure to put the minus 10 in brackets before we square it, minus 4 times 11 times minus 225, and then that's all over 2 times 11. Doing this once with the plus and doing it once with a minus, we end up with two answers, with p being 5 and p being minus 45 over 11. It's already specified up here, though, that p is a positive constant, so 5 is the value that we will take. And also the show p is 5 here. Now that we have this p, we can work out what the common ratio is. If we remember that either of these fractions individually equaled the value of r, so let's just pick the left-hand one. So you've got 5 times 5 plus 20 over 3 times 5 plus 15. 5 times 5 is 25, add 20, 45. Here, 3 times 5 is going to be 15, add 15 is 30, and if you divide through by a common factor of 15, that gives you a common ratio of 3 over 2. Finally then, just to wrap this up, find the sum of the first 10 terms in the series, giving your answer to the nearest integer. Okay, we're to sum, so the sum of the first 10 is going to be, just from the formula from before, a minus 1 minus r to the power of n over 1 minus r. We know in this case already that our r is the 3 over 2, the n will be 10. Just for the a, again, now that we know what p is, in that it's 5, first term was 4p, so just 4 times 5, that's going to give us 20. So here we have 20, open bracket, 1 minus 3 over 2 to the power of 10, all over 1 minus 3 over 2. And if you put that into your calculator, and you'll get an answer which, rounded to the nearest integer, should be 2,267.